Hey everyone! So I have just finished one of my animation exercises, which is a shooting cannon, and its goal was to practice anticipation and squash and stretch and get more comfortable with animation. And in this video I want to create a short making of to just take you through the process of making this animation. Okay, so I began by just setting the few main keyframes to plan out my animation. So I set up my camera and I have created my rig. In my separate video you can see the description of this rig and the way to download it. Anyway, so I have created this rig, put it into the scene and created main key poses. So first of all, the stationary cannon just stays at the beginning of the animation. Then it needed to squash in anticipation of the of the main action, and then it stretches as it spews out the cannonball. So this is the moment it shoots. Then the next keyframe is that it recoils back and lands into the ground, and then it was supposed to bounce back and gradually slow down, and this would be the final frame where it stops its motion. So once I have done these keyframes, I have moved on to the next stage, which is breakdowns. There is not very many breakdowns in this scene, so basically the first few keyframes are still the same. What I have added over here is that I wanted to add one frame between the anticipation and the shooting frame. So over here I have added a one frame where I have adjusted a little bit squash and stretch and trajectory of the cannon. Then I have added the frames of bouncing of the cannon bouncing up and down on the ground. So here this frame is the first keyframe where it lands on the ground, and then I have added several bounces, just animating the translate Y of the cannon placer, so it translates up, down, up, down, up, down, up, down, and it gradually decreases. Next up, I needed to figure out the timing of the animation. So what I have done is just select these keyframes and spread them around the timeline so to create a rough timing that would just generally make sense. So it looked pretty nice at the basic point to get started with. And then in the next step I have been polishing my animation, so I've been moving around my keyframes and adding some details, and finally this is how polished animation looked like so. So I have learned a bunch of things and I wanted to point out a few of them to you. So first of all, as the cannon prepares in anticipation, it was like if you select this control that controls the squash and stretch, you can see the curve, the animation curve of the squash that controls the squashing of the cannon. So basically what you want to do is for it to start slowly like so. So the motion is slow at first, then it speeds up, and then at the end it slows down when the cannon is about to shoot. And here at the end of this curve I have added several keyframes that looks like so, and this creates the nice jitter at the beginning, so that it strains so much that it jitters before it shoots. So basically you want this curve to continue slowing down in anticipation, but then you create keyframes that generally take the curve a little bit down, then a little bit up, then a little bit down, then a little bit up. And the cool thing I need to figure out here is that as opposed to the curve, so the whole curve gradually slows down. So at first it squashes quickly and then it squashes slowly, but the jitter of the animation extends increases its amplitude. So at first it has very little amplitude, so it jitters very little, and then the final few jitters are pretty big. So then finally it finishes jittering, and then it spews out the cannonball. And here it was important for me to add one frame at the moment where the cannon extended completely. So at first I had just one frame of anticipation, then one frame in between, and then the frame of the cannon spewing out the cannonball. And at first animation didn't look very well, so I needed to add one more frame where the cannon is basically at the same position, and it made animation look a lot nicer, so I liked it much better. So it makes this like adds punch to the cannon shooting thing. Okay, so next up the cannon lands on the ground and it basically bounces up and down. It bounces like a regular bouncing ball. So if you have done a bouncing ball exercise, it's pretty much the same thing over here. So if you can select the cannon placer, you can see the animation curve for the y-axis. So basically at first it's at 0, then when it shoots it jumps up. So you can see this big spike, and then as it lands on the ground and bounces, this curve gradually and smoothly decreases like so. So every bounce is smaller and smaller and smaller, and every bounce is faster. So the first bounce took like 1, 2, 3, 4, 5. So in total it was 10 frames. The next one took like 1, 2, 3, 4 up and 4 down, so 8 in total. Then 2, and then 2 again, and then 1, 1, 1, 1, 1. So it just does a little bit bouncing up and down at the end. And as the cannon moves backwards, if you can see its translate curve at at the axis, so the curve that moves it backwards, it just gradually and very slowly slows down. And here what I needed to learn is that you want to make it pretty long, so don't be scared to take the animation pretty long. So like it took around 10 frames for cannon to finish shooting, and then it was long for a few seconds. It was just slowing down and moving backwards. So that curve looks like so. And one more thing I wanted to point out is that when it anticipates the motion, you don't just want to squash the cannon, but you also want to move it backwards a little bit. It made animation look a little bit nicer, so that as it anticipates, it even moves backwards a little bit. Its wheels move backwards a little bit, so that's pretty nice. And then it shoots and bounce, 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 and slowly, gradually slows down. And then I have also added the final frame that at the end of the animation it moves backwards a little, moves forward a little bit. So like just a tiny amount, you see it moves forward. And I have also added at the end of animation that the barrel tilted forward a little bit, like so. So it just created a nice finishing touch to the animation. So basically that's pretty simple, pretty straightforward exercise. I have enjoyed doing it and I highly recommend you to practice it. So that looks pretty great. And one final touch that I needed to add to the animation is to make the wheels to turn as the cannon moves backwards. Basically what you can do is to just animate the keyframe on the wheel rotation, and then the wheels will just gradually rotate, and you can edit animation curves to make them gradually slow down at the end. But I wanted to do it automatically, so I have created a nice little formula that rotates the wheels based on the cannon movement on the z-axis. So for example, if you can see, if I select the cannon placer and move it backwards and forwards like so, the wheels will move automatically and stick to the ground. I think it's a pretty cool trick that makes animation look very nice and much faster to create. So here's how it works. Here's the formula. It looks like so. And basically this part of the formula calculates a circumference of the wheel. So what I have done is took a wheel's radius. So I've measured the radius of the wheel, and it was like so, like 0.868, and then I multiplied it by 3.14, which is a pi. So if you know probably from high school geometry, a circumference of the circle is 2 multiplied by pi multiplied by radius of the thing. So this part of the formula calculates the circumference of the wheel, and that basically determines the length that it must travel to turn 360 degrees. So like whenever the cannon moves forward this distance, it needs to turn 360 degrees, the whole revolution. And then I have taken this parameter, translate that, and copied parameter, and I can go here and select paste copied relative references, and this is the reference to translate the channel. And then it takes the translation during the z-axis and divides it by circumference of the wheel and multiplies it by 360. And as a result, the wheel naturally sticks to the ground, and I thought it was a pretty fun thing to do, so I did. But again, if you don't want to do all this math and all of these formulas, you can just, manually animate the curves, and it will look just fine, like so. So basically, I think I have explained everything I wanted to talk about. I have also created a rendering setup. You will be able to download it, both rendering setup and the rig, by following the links in the description of this video if you want to do this exercise yourself. And well, I'm not going to go through the rendering setup. The only thing that I want to point out is that you probably want to turn motion blur when you're rendering the animation. That makes it much nicer. So like when render spews out, you want it to be blurred, and this is really makes it much prettier. Anyways, you will just download the asset, and it already has all of the parameters set up properly, so it will just create the rendering for you. So, well, if you have any questions, you can ask them in the comments, and I hope this video was useful to you. If you are going to create the animation yourself, I hope that you will share the link with me so that I would see your progress. And if something is unclear, I will be happy to explain it to you further. At the moment, it's pretty hard for me to just shoot the tutorial explaining it step by step, but maybe in the future I will just take you through the whole process of creating animations. But for now, I'm just struggling to shoot videos, and so I need a little bit more practice at that. So I just I'm just going to be making offs of the exercises that I create. So I hope this was useful to you, and I'll see you in my next video. Oh guys, and there is one last thing that I forgot to point out. So if you select this barrel control that controls the tilt of the barrel, and if you look at this animation curve, it looks like this. So I just wanted to tell you a very simple thing that is probably obvious, so that when the cannon bounces up and down on the ground, you want the barrel to tilt in the opposite direction. So when the wheels are at their highest point above the ground, you want the barrel to be tilted as low as possible at its lowest point. And then when the cannon lands on the ground like so, the barrel tilts upwards. And then as they bounce up again, the barrel tilts downwards again. So it basically moves in the opposite direction of the wheels. So it's a nice little rotation over here. And then as the cannon slows down, the final few bounces, the tilt will just gradually decrease, like you can see over here. So as the cannon stops, it just boom, just slows down like so. So that's one more thing that I wanted to tell you. Oh, so there you go, that's it.